أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. Dear students, this is your teacher Noman Zaman, and today we'll be discussing the chapter number 1 of class 10, that is chemical equilibrium. Okay, well boys, first of all I'm going to start the topic with the topic that is chemical reaction. What is chemical reaction? As you have already studied in your previous classes, that chemical reaction is the process in which one or more substances converted into one or more different substances. And here we mean one or more substances. This term will be called as the reactant in general terms. And on the other side, the term different substances. This different substances term, we mean that product. So we can shortly say that the reactant converts to the product. This process is called as chemical reaction. For example, there are different kinds of examples you have already studied in your syllabus. That is, zinc reacts with hydrochloric acid to convert into zinc chloride and liberates hydrogen gas. Okay, let's move ahead. Under the umbrella of chemical equilibrium, the chemical reaction can be categorized into two main types, that is irreversible reaction and the reversible reaction. We'll dwell upon them one by one. So first of all, irreversible reaction. Irreversible reaction is a reaction in which the product do not recombine to form the reactant again. Means product will not shift back to the reactant. Once the product is formed, that is full and all, it will not return to its initial condition. It is generally represented by an arrow, and arrow is pointed from reactant to the product side. The common examples are burning of wood. When the wood is burnt, the wood converts into the ash and the gases that evaporates. Similarly, another example, that is a chemical example, that is magnesium. When reacts with hydrochloric acid, it produces magnesium chloride and hydrogen gas is liberated to the outer atmosphere. Well, move ahead. Reversible reaction. What is reversible reaction? This term is new to you. Reversible reaction is a reaction in which product can recombine to form the reactant again. Means product recombine to form the reactant again. Generally, it happens that when reactant reacts, it produces a product. The product is final and doesn't react back. When in case of reversible reaction, the product reacts with one another and converts back into the reactant again. They are generally represented by double arrow. As you can see, the two half arrow. These two half arrows represent the two types of reaction. The upper arrow, it represents the forward reaction, and the lower arrow, which is pointing towards the reverse direction, it represents the reverse reaction. Okay, example of reversible reaction is mercurious oxide converts to mercury and oxygen. Now, in this reaction, it generally happens that the mercurious oxide decomposes into mercury and oxygen, whereas on the other side, the mercury and oxygen reacts together and converts back into the mercurious oxide. The two simultaneous reactions keep on taking place. The mercurious oxide converts to mercury and oxygen converts back to the mercurious oxide. The basic and the only condition that is required for reversible reaction is that reaction must be carried out in the closed container. If you are having closed container, reversible reaction is possible. And if the container is open, there is chance that either reactant or product may escape from the system in the form of gases or volatile components. They just escape through the beaker or the reacting material and they just leave the system. So the only and foremost condition required, the basic condition required for reversible reaction is closed container. Okay boys, the graphical representation of dynamic equilibrium. In this concept we will be discussing what is dynamic equilibrium and how equilibrium establishes. Generally, what happens when a chemical reaction takes place, that A plus B, that is the reactant side. This reactant side converts to the product side, that is, here I am representing the product from with letters C plus D. The reactant converts to the product. Generally what happens is that in the beginning the reactant starts to react. Here the whole process is represented in terms of graph. The graph on the y-axis side, rate of reaction is represented. What is rate? Rate means, you have already studied in your physics that here the rate means speed of reaction. And on the x-axis side we are representing the time, that with the passage of time what happens to the chemical reaction. In the beginning the reactant, that is A plus B, the concentration of reactant starts to convert into the product side. Once the concentration starts to convert into the product side, the concentration of reactant decreases. When the concentration of reactant decreases, the rate of conversion of reactant into product also decreases. As you can see in this graph, with the passage of time, the reactant speed or the rate of reaction decreases. The graph is going downward. See? Whereas on the other side, once the reactant starts to convert into the product concentration increases. And when the product concentration increases, rate of reaction also increases. Means the product, as you can see, with the passage of time, the product is going upward. Means conversion of product to reactant also starts with the passage of time. And this reaction gains speed as time passes on. As you can see in the graph, the product graph is going upward. A time comes when the reactant, as you can see, its speed is gradually decreasing. On the other side, the product speed gradually increasing. A time comes when the both rate of reaction matches one another. At this point, the reaction seems to appear as it is stopped. Reaction is not stopped. It seems as that reaction is stopped, and that condition is called as equilibrium condition. When the rate of forward reaction becomes equal to the rate of reverse reaction, when these two rate of reactions becomes equal to one another, that condition is called as dynamic equilibrium state. That condition is called as dynamic equilibrium state. The main points that I extract from this graph are: with the passage of time, forward reaction slows down. As you can see in this graph, with the passage of time, the reactant converting to the product, this reaction is slowing down. With the passage of time, reverse reaction speeds up, gains speed. As you can see in the graph, as the time moves on, the product, that is the reverse reaction, it is speeding up, it is gaining speed. And when the rate of forward reaction becomes equal to the reverse reaction, that condition, that time is called as dynamic equilibrium. Thank you, boys. Okay, the last point, as we were discussing the 2 points frequently and continuously, that is the forward reaction and the reverse reaction. Actually, what are the forward reaction and the reverse reaction? Quickly, forward reaction. Okay, forward reaction. Forward reaction is a reaction in which the reactant converts to the product. That is, conversion of reactant into product per unit time is called as forward reaction. The main features, the main characteristics of forward reactions are that in this reaction, the reactant converts to the product. They take place from left to right. They are usually represented from left to right. That is, for example, A plus B converts to C plus D. So, as you can see, AB is the reactant and C plus D is the product. And A plus B is on left side and C plus D is on right side. So, these reactions generally take place from left to right direction. Initially, at initial stages, forward reaction is very fast and later on it slows down gradually. Reverse reaction. Conversion of product back into reactant per unit time is called as reverse reaction, or the product converts back into the reactant is called as reverse reaction. The main features, the main characteristics of reverse reaction are: product react to form reactant, that is, the product is converting back into the product, that is, here C plus D is the product, it converts to A plus B. So, this condition is called as reverse reaction. They generally take place from right to left. If you consider a reversible reaction, that is, A plus B converts to C plus D. Here, A plus B, which is generally the reactant, and C plus D, which is generally the product. Here, the C plus D, which is product, converts back into the A plus B, that is the reactant. So, C plus D is on the right side and A plus B is on the left side. So, the reverse reaction generally takes place represented by taking place from right to left direction. In the beginning, rate of reverse reaction is negligible, as you have already seen in the graph. In the beginning, it is almost equals to 0, and it speeds up gradually with the passage of time. Thank you, boys. If you have any question related to the topic, please WhatsApp me in the group. Thank you, boys. Allah Hafiz.